All right, well, trust you did well on that quiz. We have just a few minutes. Wanted to go over very quickly some guidance for you in the lessons ahead. Monday will be our review day, so we'll be playing a review game once again. Last review game wasn't awful. I've had years where all three students were in the negatives at the end. Okay, it wasn't that bad, but it wasn't stellar either. So put a little studying in over the weekend, over chapters 3 and 4, so that you'll be ready for the review game and can dominate the competition. Tuesday, that's lesson 26, will be your test over chapters 3 and 4. Real quick, I want to go over the equations from chapter 3. Obviously, terms you can review on your own, but I want to review over those equations with you very quickly. The first equation was kind of the definition of pressure. P equals F over A, right? Force per unit area. But we also talked about liquid pressure. And we said liquid pressure depends primarily upon depth. So we had an equation we called the law of liquid pressure. What was that equation? P equals rho GH. We also had a similar equation that we could use to find the force that's brought to bear on the bottom of a container. F equals A, rho GH. We said, however, if we're finding force on the side of the container, we would use the equation. Good. We refer to this as lateral force because it's a sideways force. Similarly, then, if we wanted to find average lateral pressure, that equation would be good. So it's sideways, we just take a half on it to average out because at some points it'll be more, some points less. We had talked about hydraulic devices, remember, how they multiply force, but you have to put in more distance on the hydraulic device. Right? You have to push the brake pedal in 3 or 4 inches to get them to really grab, and the brake calipers really don't move very far at all. They don't need to, but they have a great deal of force as they move. Okay, so you put in more distance, but they put out a lot more force than you could ever hope to put out, right? So a hydraulic device multiplies force. What equation shows that? Okay, so remember in a hydraulic device, the pressure is everywhere the same because you're using a confined liquid. So it's F over A equals F over A. All right, so there's your hydraulic equation. What can we put instead of A? Diameter squared. Because there's an A on both sides, we can do that. But also, however much liquid you push out of the piston that the brake pedal is attached to is how much brake fluid goes into the brake lines out to the calipers. You don't get more volume of liquid. The volume stays the same. What equation shows that volume remains constant? A1H1 equals A2H2. And again, you could substitute diameter squared for the area. We also talked about Archimedes' principle, right? Objects floating. And I said we've got 2 equations. One for the weight of the object that bears down, another for the buoyant force that acts up, and they're the exact same equation. Rho VG. You might want to be right. It would be nice to maybe make a little equation sheet with these. That might be a wise idea. The difference is the density for the buoyant force is the density of the liquid. And here, for the weight, it's the density of the object in question. Right, the volume will be the same, the gravity will be the same. By the way, we assume for all of these that involve G, stay with me real quick, we assume G to have what value? 9.80 meters per second squared. Also, if it's water, we're going to assume rho to be what? 1,000 kilograms per meter cubed. You could write some of these things down. Okay, so, or you can go back and watch the video like Kendall's doing. Yeah, so these memorized values, be good to know. And then last of all, we had the principle of continuity equation. Remember where water flows through maybe a series of connected pipes. And as the pipe widens, the water or the liquid is able to slow down. And as the pipe narrows, the liquid has to speed up. What was that equation? Good. Good. And yeah, you're right. So on and so forth, if you had multiple sections, where again, because there's an area on both sides, area could still be replaced by a diameter squared. But area times velocity, cross-sectional area times velocity equals cross-sectional area times velocity. So here's your equations, your facts you'll need to know for the math from chapter 3. We'll review that in our review game, hopefully, if you choose math column questions. And obviously chapter 4, we had a good thorough review today. All right. Well, you are dismissed. Study hard over the weekend and be ready for the review game and then the test coming up Monday, Tuesday of next week. That's not what I want to do. Hold on. It's still recording because something's not working right. What are you doing to me? Hi, Kendall.